Algebra 1, Factorising. So in the last class we looked at type 1 in factorising, which was the highest common factor, and then also type 2, where we had to group a couple of terms and take out the highest common factor, and then take out the highest common factor a second time before we could factorise fully. So today what we're going to be looking at is difference of two squares, difference of two cubes and sum of two cubes, and then factorising quadratics. So we're going to start with type 3 here, which is difference of two squares. So our rule for difference of two squares is if we have something squared minus something squared, hence the term difference of two squares, then when we factorise, what we get is x plus y times x minus y. Now we need to put a big fat NB next to this because this is not in our maths tables. So we need to learn this one off by heart. So say for instance we're asked to factorise x squared minus 25. Then what we have to look at is, can we write this as something squared minus something squared? And of course we can, because x squared is x squared, and then 5 squared is of course 25. So therefore if I'm looking at the formula, this is x in my formula, and this is y in my formula. So it's going to be x plus y, in other words, x plus 5, times x minus y, which is of course x minus 5. And now we have factorised fully. Okay, so if we look at a second example, where again we want to factorise 36 a squared minus 1, then again we have to see, is this the difference of two squares? So of course there should be only two terms, and it should be something squared minus something squared. So if we take 36 a squared minus 1, what will go in the first bracket and what will go in the second bracket? So of course it's going to be 6a to be squared, because 6 squared is 36 and a squared is a squared. And the second bracket is just going to be 1, because 1 squared is itself. So if I look at my formula, that's going to be my x term and that's going to be my y term. And therefore that gives me 6a plus 1 by 6a minus 1. So in other words, x plus y by x minus y. Okay, so if we look at type 4 next, where we're looking at our cubes. So for type 4, sum difference of two cubes, what we're going to have is x cubed plus y cubed. So something cubed plus something cubed will be our sum of two cubes. And our rule then is x plus y times x squared minus xy plus y squared. And again, not in our maths tables. And if we look at the difference of two cubes, so x cubed minus y cubed, the only thing that changes here in the rule is the sign. So in other words, we have x plus y becomes x minus y, and then the minus xy becomes plus xy. So we need to know both of those off by heart, along with our difference of two cubes, our difference of two squares. Okay, so let's have a look at an example. So again, we're going to factorise. And the first one we're going to do is a nice simple one. So x cubed minus 8. So of course, we look at x cubed minus 8, and we can see there's a minus this time. So again, it's going to be the difference of two cubes as opposed to the sum. And we have to say, well, can I write it as something cubed minus something cubed? So of course, it's going to be x cubed, and what number will multiply by itself 3 times to give us 8? Well, it must be 2. So 2 by 2 by 2 is 8. So if we look at our formula, x will be x and y will be 2. So therefore that's going to be x minus 2 by x to be squared plus x times y, so in other words x times 2, plus y squared, so in other words 2 squared. So we have to be careful here to make sure we're using brackets when we're subbing in, so we don't make a mistake. So that's going to be x squared plus 2x plus 4 times x minus 2, and we are now factorised fully. Let's have a look at another example. So here we're going to factorise 3x cubed plus 648. So if we look at this one, well, straight away I can see, well, 3 isn't any number multiplied by itself 3 times. So I can't get something cubed plus something cubed here. However, if I go back to type 1, where I take out a highest common factor, well, that leaves me with x cubed plus 216. And now I can see that I can write it as something cubed plus something cubed. So sometimes we have to simplify a little bit before we can actually apply our formula. So therefore that's going to be x cubed plus 6 cubed. So 6 times 6 times 6 is 216. So you can always use your cube root formula on your calculator if you can't see the answer straight off the top of your head. So if we apply our formula then, x is going to be x and y is going to be 6. So it's going to be x plus y, in other words x plus 6. And then it's x squared, and then it's going to be, we go back to our formula there, so it's x plus y by x squared minus xy plus y squared, yeah? So it's going to be minus x times 6 plus 6 squared. So again, if we tidy that up, that's 3 times x plus 6 times x squared minus 6x plus 36. And we're asked to factorise, so we keep out the 3. We don't multiply it back out again, okay? Because otherwise you're not fully factorised. Okay. So if we look at one more here, we have factorised 64a cubed minus 1. So again, we want to see, can we write it as something cubed minus something cubed? And we can. So 4 by 4 by 4 is 64. And of course, 1 by itself 3 times will give me 1. So here we have our x and our y in our formula. And we saw that when we had x cubed minus y cubed, we had x minus y by x squared plus xy plus y squared. So if we sub that in, then we have 4a minus 1. And again, really important here, 4a squared plus 4a times 1 plus 1 squared. So always making sure you're using brackets when subbing in, especially in the second part of the formula. Because you'll see here, 4a squared is 16a squared. And sometimes students forget to square the 4, leaving them with 4a squared, which is, of course, incorrect. So it's all of that first term to be squared. And then 4a times 1 is just 4a plus 1 squared, which is 1. And now we are factorised fully. Okay, so let's look then at the next type. So type 5 is where we're going to factorise our quadratics. Now, of course, you can have used the scissors method or the box method for this in junior cycle. So I'm going to show you the method that I use, which is kind of the traditional method, which involves grouping and highest common factors. So our type 1 and our type 2 types of factorising. So it might seem like a little bit of a longer method, but it's basically the idiot-proof method, which means that no matter what quadratic you have, whatever signs you have, whatever coefficient. So here we're being asked to factorise x squared minus 3x minus 18. So what we want to basically do is we look at the coefficient of x squared, which is 1, and we're going to multiply that by the last term, which is 18. So we have 1 times minus 18 is minus 18. And we then look and we say, well, what are the factors of minus 18 that add to give us minus 6 or minus 3? So obviously factors of 18, Well, you could have 18 and 1, okay? You could have 6 and 3. And of course, 6 and 3, well, one of them has to be negative to give us minus 18. And if I have minus 6 by 3, I get minus 18. But also, if I subtract the 3 and the minus 6, in other words, if I add minus 6 plus 3, I get minus 3. So therefore, this is the set of factors that we're looking for, not 18 and 1. So I then take those two factors and I replace them for the minus 3x. So that gives me x squared minus 6x plus 3x minus 18. So in other words, I have to make sure I put them in terms of x. I then take the first two terms and I take the highest common factor. So in other words, I'm grouping and taking out the highest common factor, which is x, leaving me with x minus 6. And the highest common factor between 3 and 18 is 3. But this also leaves me with x minus 6. So in other words, I got the highest common factor there. But you can now see that I also have x minus 6. In other words, I have another highest common factor. And that leaves me with x plus 3. So in other words, when I factorize the quadratic x squared minus 3x minus 18, I end up with x minus 6 by x plus 3. And then you're not kind of doing this kind of guesswork of what numbers go in the brackets and what sign goes in. So you're not doing your guesswork. You're following a very simple process of highest common factors once you figure out what the first two factors need to be. So let's have a look at another example. So if we factorize 5x squared plus 12x plus 4. So again, we look at the coefficient of x squared and we're going to multiply that by 4. So we have 5 times 4 is 20. And we say, what are the factors that multiply to give me 20 and add to give me 12? So of course we can have 5 and 4 multiply to give us 20 because we just saw that, but they don't add to give us 12. So they're not the right factors. And of course you should have spotted straight away really that it was going to be 10 and 2. And of course 10 and 2 will multiply to give me plus 20, but they also add to give me plus 12. So I don't need to change any signs here this time. So I simply take the 12x and I'm going to replace that with my two factors there, 10 and 2. So that gives me 5x squared plus 10x plus 2x plus 4. And it doesn't matter which order we put in the 10x and the 2x. So if you put in the 2x first, when you go to take out the highest common factor, it'll just be x. Whereas if I put in the 10x first, I'll have a different highest common factor, but we still end up with the same answer at the end. So my highest common factor between the first two there is 5x, leaving me with x plus 2. 2 is my highest common factor between 2x plus 4, leaving me with x plus 2. And again, I now see that I have another highest common factor, which is x plus 2. So if I take out x plus 2 as being common, that leaves me with 5x plus 2. So therefore my factors of 5x squared plus 12x plus 4 is x plus 2 by 5x plus 2. So I'm going to do one more and then we're going to be doing questions off the worksheet I gave you the last day. So here we have factorize 3x squared plus 10x minus 8. So again, we take the coefficient and I multiply it by the last term there. So we have 3 times minus 8 is minus 24. And we have to say, well, what multiplies to give us minus 24 and adds to give us plus 10? So this time it must be, again, 12 and 2, but it's going to have to be plus 12 and a minus 2, because they must multiply to give me a negative number, so they have to be opposite signs, but they have to add to give me plus 10, so that means the bigger number has to be positive. So I'm going to take my 10x and I'm going to replace it with my 12 and my minus 2. So that's 3x squared plus 12x minus 2x minus 8. If I group the first two and take out the highest common factor and group the second two and take out the highest common factor, well, my highest common factor between the first two is 3x, leaving me with x plus 4. And if I take out minus 2 as being common between the next two, then that leaves me with x plus 4. Now, if you took out plus 2 there, then that would leave you with minus x minus 4. And you would see then that you wouldn't get these two brackets to be the same. So you always want those brackets to be the same. So if your sign is wrong, you won't end up with the same bracket. So just go back and check, okay? So again, highest common factor we have is x plus 4. And if I take out my highest common factor, that leaves me with 3x minus 2. So in other words, the factors of 3x squared plus 10x minus 8 is x plus 4 by 3x minus 2. So now what you're doing is you're doing the marked questions on the worksheet I gave you the last day. And they're for class tomorrow.